This is section 5.3, the indefinite integral. In this video, we're going to go through example 49 in your book, and this is a problem that's asking us to find the initial value of a function. So 49 gives us that dy over dt is equal to this function, and it also tells us that y of 1 is equal to 2. Okay, so initial value problems are really just asking us to find the original function. Right now, we're given the derivative of some function, and we're given a point on the original function, but they want the actual whole original function. So before we go through this problem, let's first talk about the relationship between the derivative, original function, and the integral. So we know that if we have the original function and we want to get to the derivative of the function, we just take the derivative. To go from f of x to f prime of x, take the derivative. On the other side, if we have f of x, we want to get big F of x, we just take the integral. And this is true for however many functions we want to find the derivative of, or how many times we want to take the integral, right? So if we're traveling this direction and we have big F of x and we want to find the original function, we can take the derivative of big F of x and we'll end up with our original F of x function. And on the other side, if we have f prime of x and we want to get back to our original function, we just do the opposite of the derivative and we take the integral. And this is the relationship we're going to use in this problem. Okay, so going back to 49, they give us the derivative, but remember they want the original function. So how do we get from the derivative to the original function? We have to take the integral. So I'm going to take the indefinite integral of this function, and afterwards I'm going to solve for c using my point. So take the indefinite integral of 2t plus 9t squared dt, and just using my integral rules, add 1 to the exponent, this becomes t squared, divide by that new number, just have 1, plus over here I get t cubed, 9 divided by 3 gives me 3. And remember, with indefinite integrals, we always add a plus c at the end. Okay, so this is my original function y, or my original function f of x. But I'm not done yet because I still have this variable here. I still have this c. So how do I solve for this c? Well, I'm going to plug in this point that they gave me up here into my function and solve for my last unknown c. So this point tells me that y is equal to 2 whenever t is equal to 1. So I'm just going to plug a 1 in wherever I see a t. Over here, 1 times 1 squared gives me 1, plus 3 times 1 cubed is 3, plus c equals 2. And now just solving for c like normal, I get that c is equal to negative 2. Okay, and now I just plug the c back into my function here, and I get that my original function y, or my original function f of x, is equal to t squared plus 3t cubed minus 2. And that's it for this question. I hope you found this video really helpful. The concepts covered in this video are true no matter what calculus class you're in, but all the sections and problems I referenced were from this textbook right here. And remember that if you're a registered Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either schedule a one-on-one appointment online or just drop in whenever you're available during our business hours for free tutoring. For more information, feel free to visit our website.